Okay. Okay, fine. So let us start. So what I was saying is we have to construct a finite automata for A plus B closer, right? Okay. Is there a message in the group? So good evening, sir. This is version one. Can you please share the recording links of yesterday class? Okay. Okay, so we have to construct the first of all we have already constructed A plus B, right? So let me do first that A plus B. So what was the machine? We have said that finally from initial state we are saying that we will be going to a state Q1 on epsilon and on state Q2 on epsilon, right? And then what we are saying that we will be moving to state Q3 on getting A and state Q4 on getting B, right? And then we are saying that we will be getting, let's say, state Q5, and this will be our final state on getting epsilon. Now, what I'm saying is, what if I will put a star? Star means what? Any number of time this A's and B's can repeat, first of all, right? So for that, what I'm going to add here is I'm going to add a back transition from here to here on epsilon. This will do what? Anytime I will follow A and I can come back. I can follow A or B again. Again, I can follow A or B, anything, and then I can come back and repeat A's and B's, A or B, any number of time. Do you follow this? Right? Now, one more thing I have to do. What is that? I have to accept epsilon also, right? So to accept epsilon, what I can do here is I can create one more state here. Let's call it anything. Q5 was there, no? So let's call it Q6 and make it as initial state. And from this, I will make a transition here. And here I will make another state. Let's call it Q7 and make it a final state. And from here, I will make a transition on epsilon, right? And now this is not my final state, right? And from this Q6 to Q7, from the initial to final, I will have a transition on epsilon. Now, this is the finite automata for A plus B star, right? A plus B star means what? Zero or more times A or B, right? So here you can see what all possibilities we have. So I can follow this path. So one time I can get A and I will be on final state. I can choose to repeat something like from here I can go here A and then I can come back, right? And then I can go to this path A B, then I can come back, then B, then B, then maybe A. So any number of time I can repeat anything, and then finally I can go to the final state, right? So any possible combinations of A's and B's are absolutely possible in this case. Now, star, this lean closer says 0 or more time. So even if A's or B's will not come even of single number of time, then also we have a transition from here to here, which is saying it will accept the epsilon move, right? Epsilon move, right? So that means what? From initial state, I can go to final state without getting any input symbol. That is, this transition is saying. Am I clear with this? How we have constructed A plus B whole star, and what are the strings valid for this? Let me know quickly in the chat box, quickly. Hmm? Is that clear? Meanwhile, you can take a screenshot of this. So A plus B closer means what? A or B can come 0 or more time, right? That is, so this is what is the regular expression, and this is what is corresponding finite automata, right? So for this regular expression, this is how we can write our finite automata. Okay, fine. Okay, great. So I hope you have taken the screenshot. Let me go to the notes now again. Okay, where are the notes? Here is the notes. Okay, fine. So regular expressions will look like this, right? So A star is a regular expression, A is a regular expression, phi is a regular expression, epsilon is a regular expression, A star is a regular expression. What does it mean? We have seen. A plus is the regular expression. What does it mean? We have seen. A plus B is a regular expression. What does it mean? We have seen. A plus B closer is a regular expression. What does it mean? We have seen. A plus B closer than A B B. Can you tell me what does it mean? Can somebody write in the chat box? Okay, it is written also here. What does it mean? It means A plus B closer means what? We already know, all possible combinations of A and B. And what this ABB is saying here, dot is not written, but we will consider it automatically there, right? So this dot is saying that whatever A's and B's can come, including epsilon, but it should end with ABB, a set of all strings of A's and B's ending with ABB. Can you make a finite automata for this? Take a minute and make it quickly. Draw the finite automata for this. A plus B closer, we have already seen how to draw. Then add ABB at the end. Yes, and that is the finite automata for this. Make it for practice. Take a minute, make it. A plus B closer, and let me know in the chat box once you are done. A plus B closer and then dot ABB. So like precedence of operators in arithmetic operations, here also in regular expressions also we have precedence of operators, right? We will see which is having more precedence and which is having less precedence, right? So have you drawn this A plus B closer and then ABB? Everybody has drawn it. Hmm? What we have to do in this? So this was A plus B closer. Only what we have to do at the end. Now this will not be our final state, of course, right? Now what we have to do after this? Okay, after this we have to write A, Q7 तक हो गया था ना, let's call it Q8, and then B, Q9, and then B, ABB, Q10, and this will be my final state. Right, that's it, done. This is A plus B closer dot ABB, right? It is accepting all the strings of A's and B's, which is ending with ABB, right? Hmm? Okay. Okay, fine. So that is what A plus B closer dot ABB. Similarly, AB dot A plus B closer. I hope now you can make this as well. It says that it should accept all the strings starting with AB, right? Starting with AB. Okay. Then A plus B closer, AA, then A plus B closer. Set what this accepting? Set of all strings of A's and B's having AA as the substring. right? So AA should come as a substring. That is the regular expression for this. So this is what I think now you are getting the idea of what a regular expression is, right? So regular expressions are nothing but a representation, you can say, of regular languages, right? So we represent regular languages with the help of these operators, right? Similarly, A closer, B closer, C closer, what does it mean? It means string consisting of any number of A's, any number of B's, so followed by any number of B's, followed by any number of C's. Now, for example, for instance, can you try designing a finite automata for this? A closer, B closer, C closer. Anyone? How to construct A closer, B closer, C closer? Hmm? Take a minute, think. Then only your thought will develop. A closer, B closer, C closer. How to construct the finite automata for this? Anybody in chat? In short, also you can write, or you can raise your hand. I'll unmute you. Then you can explain what is your idea. Hmm? A closer, B closer, C closer. How to construct a finite automata for this? A closer, B closer, C closer. Hmm? Anyone? This is a regular expression. Now we have to construct a finite automata. Why I'm constructing this finite automata is just to give you an idea, because you already have drawn a lot of finite automata, right? So now you can, if you will relate these things, then you will understand it better. First of all, what is the regular language which is accepted by this? So A closer means any number of times, zero or more time. B is zero or more time. C is zero or more time. So epsilon is valid string here, right? Everybody can come zero times. So epsilon, in that case, epsilon will be valid, right? Then any number of times A can come one time, two time, and any number of time. Then after A we can have B one time or two time or any number of time, or we can only have B also, A zero time, B one time. Then after A B we can have C any number of time, or we can only have C, we can have B C, right? We can have C C C C any number of time. So all these are valid, right? Now you, once you have understood the language, now try to design the or construct the finite automata. Anybody have any idea? Hmm? How to construct a finite automata for this? How the finite automata will look like? Okay. Uh, okay, you can unmute and speak.
It starts with epsilon and initial state has a loop and then epsilon. Then again the next state it has b loop. Then
Okay.
epsilon. Then it will have c state where c will be looping, and last you will have epsilon.
Very good. So she is saying, I think, is something like this. Is it what you are saying? Hmm? Well,
Yes, sir.
is, yes. Okay.
Yes, sir.
So you are right. You are correct. Right. Okay. Simran, I hope you understood, right? Simran said you understood, right? So any number of time. So whenever, let me give you a shortcut now. So whenever we have epsilon, whenever we have closer, I mean lean closer, the star on the power, that simply represent a self loop, right? Because self loop is saying zero or more time, right? So that is the nature of self loop. Simran, have you understood now? You have given me a different answer. Now, have you understood how we will construct this? A closer, B closer, C closer. Hmm? Is there a doubt, Simran? Or is it clear? You can respond in the chat box. Be quick, 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 quick. Otherwise, I can explain. I can go in detail if you have not understood. Hmm? No response? Okay, fine. Fine. Okay. Sir, can't we take another state as initial and begin with epsilon? Yes, yes, we can take, no problem. I mean, if you want me to do something like this, let's say another state Q3, and on epsilon, this will be reaching here. And even if you want to add another state as final state, you don't want to make it, sorry, we don't want to make this as final, and you want to make this Q4 as final and with epsilon. Even this is right. This is no problem, right? Hmm? Yes, yes. This is also fine, no problem. Accepting the same language. I just said why to add more states when we can do it in this. So we are drawing, if you mind, if you see here, we are drawing epsilon NFA, and we have never talked about minimization of epsilon NFA, right? So there is nothing called minimum NFA or minimization of NFA or epsilon NFA. We only talk about minimization of DFA, right? So it is also fine, no problem. You can add 2 3 more states with epsilon, no problem. You can do that. That will still accept the same language, right? Clear, right? Hmm? Okay, fine. So that is what A closure, B closure, and C closure. So whenever you have something like this, A closure, B closure, C closure, you can simply put self loops that will do the job for you, right? Let us move ahead. Okay, so A closure, B closure, C closure means what? A string consisting of any number of A's followed by any number of B's followed by any number of C's. Good. Okay, now A plus, B plus, C plus. How can you design a finite automata for this? So string consisting of at least one A followed by at least one B followed by at least one C. Now, quick, you raise your hand, I will unmute you, and then you can answer. Or you can give me an answer in the chat box. Private, public, anything you can give, no problem. So what we are saying here essentially is, okay, what we are saying here is A plus, B plus, and C plus. What will be the finite automata for this? First of all, what will be the language for this? The language will contain at least A, B, C, right? At least one time everything will come. And then you can repeat anything. A, B, C. A, B, B, C, C, anything. Any number of time A, B, C will repeat. No problem. Right? This is the language. Now we have to draw the finite automata for this. Anyone? Quick, quick, quick. How much time is? Time is around 9:30. Fine. Anyone? How to design finite automata for this? You can respond in chat or you can raise your hand. Speak. Hmm? It is very simple. No one? Strange. No one? Hmm? Hmm. Yes.
It,
Oh, sorry. Sorry. Unmute. One second. Yes.
it has A, then self
Hmm.
loop A, and then epsilon.
Just a second. Let me draw. You are saying
Uh,
initial state, we will have a transition on
we
A.
have A,
Okay. And then
self
a
loop A,
self loop of
self
A,
loop
and then
A, epsilon.
self loop of B.
Uh,
I think you are saying this.
epsilon. No, Q1 to Q2 is epsilon.
Epsilon. Okay. Okay. And then
And then here it will be a B.
here it will be B. Okay.
You don't have self loop for Q2. So
We
Q3 will
don't have
have
self
self
loop.
loop.
Q3 we will have self loop of
Self loop. Yeah. B.
C.
B.
B again. Okay.
Yeah. You don't have
And then
self loop for Q2.
we will not have self loop for Q2. Okay.
Q2, huh? Uh, and it
Okay.
repeats like C and then self loop for C.
So one transition again epsilon or C?
C.
C. Okay. And then Q4
And
maybe.
then,
And
yeah,
then
self loop for C, self loop for C,
okay. And who will be the final
epsilon
state?
with
Q4.
unit Q.
Okay. Epsilon and
Yeah,
then Q5 that will be final state.
Q4.
Okay. Can you tell me now the purpose of these epsilon moves? Hmm?
Even without uh, uh, ABC, you can just get without looping, you can just
Yes.
come to the final state.
No, looping is required, but without epsilon move, we can do like we can say something like this, right? Sorry, B and then Q2. We can have a self loop of C, then C, and then Q3. Is not it okay? I think it is okay. What is the problem in this? Is it okay now? So any number of times A can come, minimum one time A I am counting. So then any number of times B's can come, minimum one B I am counting. Any number of times C can come, minimum one C I am counting. Is there a doubt in this? Hmm?
No, sir.
Is it okay? Okay. Fine. So right. So this could be the solution for A plus B plus C plus. Now I think you must have a better idea of how we are constructing, these regular expressions, right? What is a regular expression? So similarly, we will have a lot of varieties of regular expression. Like for all those we have drawn the finite automata. I will share this notes with you. You can try for in notes they have not drawn the finite automata for them, so you can try finite automata for all these, and that will give you a better understanding of all these regular expressions, right? Okay, like A plus B and A plus B, what does it say? Strings of A's and B's with length 2, right? With at most length 2. This is not the right statement. This would make the statement like this. What this A plus B and A plus B is saying, this is saying that length of string of A's and B's with length at most, with length at most 2, at most 2, at most 2, right? Right, that is the meaning of this. At most 2. Why at most 2? At most, what could be the string? One A or B can be taken from this, one A or B can be taken from this at most. So at most A B, B B, B B, and AA, both from both AA can come, then from both BA can also come, from first B and second A. This is and epsilon is also valid because no, epsilon is not valid because closure is not given. So this is the language for this. If you see, this is the regular language for this. AA, AB, BB, BA. Do you understand this? So what is this regular expression is saying? This regular expression is saying not at most, actually exactly 2. The this is exactly the string of A's and B with the length exactly 2, exactly 2, right? Exactly 2, not less, not more, not possible. Exactly 2, exactly 2, right? So this is the regular language for this. Now at most 2, can you write a regular expression, anybody, for a string of A's and B's with length at most 2? At most 2, this is exactly 2, at most 2. Anybody can raise hand and speak. At most 2. What will be the finite automata? Hmm? Strings of A's and B's with length at most 2. Hmm? Right? Yes, this is at most 2, but epsilon will also be added, Richa, in this. So what you can simply do is at most 2 is this is exactly 2, right? This is exactly 2. And now at most 2 ke liye, what we have to do, we put a closure on this. Right? This will be at most 2. What will be at least 2? So what this you have to understand what is this? This is what from here either A or B can come. Either A or B can come. From here either A or B can come. Right? Uh, so at most 2 is not this actually. Uh, so this can come more number of time also. So any possibility of A's and B's are possible. At most 2 means what? At most 2 means um so epsilon, yes. So Richa has said a right thing that first of all, what will be the language? The language will be epsilon, then A, then B, then AB, AA, BB, and BA. So what will be the regular expression for this? So so A or B can come, right? And yes, A or B can come. And one more thing we have to add with this. Uh, so we have to add A plus epsilon and B plus epsilon. So that will be making a length 3. Length at most length 2 will be epsilon plus this. So either epsilon or any one of them, right? Or concatenation is also fine. Epsilon concatenation with this is done. This is what is the a regular expression for at most 2. Some messages are there. A plus B plus A plus B. A plus B plus A plus B. Hmm. But epsilon is not getting covered in that, right? Uh, right. Okay, so you can do something like this, right? Hmm? Okay, fine. So so do practice today. We have when exhausted our time now. So so you can try a lot of possibilities. And in next class, we will be discussing about a regular expression to epsilon NFA and epsilon NFA to regular expression. We have already seen this in this class also, but in next class we will be doing a lot of more practice, and formally I'll be defining the the steps for doing this, right? So just wait for 2 minutes. I will be recording your attendance for this. Just hold on. Yeah. So, okay, fine. Thank you. Send message that, sir, tomorrow, when do we have class? Okay, what do you want? The same time is fine. I think everybody is there at home and coolly you can attend these classes. Yes, sir, please send the document for today. Yeah, I'll be sending. Yes, sir. So this time is fine, right? Everyone. So we will have tomorrow's class at this time only, right? From 8:30. So that, sir, can we get the recording of for this? Recording, see, I can share, but once I will share the recording, why will you attend the class then, right? So I'll be sharing. uh, actually I was finding yesterday somebody has sent me a message that share the recording. I tried to share it. I think it is saved in somewhere in my documents or something. Sir, can we submit the assignment on Monday? Um, Fine. Okay, no problem. See, as far as I can do, I don't want to make any trouble for you. So fine, you can submit on Monday, no problem. While you are coming for your test, then you can submit, no problem. Fine. So welcome it. So tomorrow again at the same time we will be conducting our class, right? And you all can join. I'll be sharing the link tomorrow, and you can join, right? So tomorrow and day after tomorrow, in two classes, we will finish at least this regular expression part. Until this, you will be getting questions in your in IA1, right? Okay. Fine, guys. Thank you for your patient hearing. We will again meet tomorrow. Till then, good night, and thank you again. Thank you.